Hi, everyone. I'm Celine Armstrong, your moderator for today. Thank you for joining us for a short video tour of the park, followed by a panel discussion. And just as a housekeeping note, there's live caption available in the link in the chat for those who need it. Let's go on tour.
Hi, I'm Celine Armstrong, project executive for Little Island. I essentially manage design and construction for the client team. Construction commenced in July of 2016 with our first pile. It was a really big milestone for this project. And zoom forward a few years, look around and see that we have our pots, soil, and the landscape is going in. One of the greatest joys that I have is working with our amazing team. We have two of them here today. They're wildly talented and fully collaborative. That's David Farnsworth. He's a principal at Arup in New York. And the other is Signe Nielsen, and she is the pioneer for landscape architecture in New York City with 40 years of experience and is creating an oasis for New Yorkers.
Hi, I'm David Farnsworth from Arup here in New York. We're the multidisciplinary design engineers for the project, along with the architects on the team. So the complex geometry for the pier required the use of parametric design software in order to generate the geometry for all of the structural shapes on the pier. The tulip-shaped pieces that you see behind me we call pots. They sit on precast piles that have been driven into the river. The external shape was generated by the architectural team at Heatherwick Studios. The structural team then took those external shapes and used parametric scripting to create the interior geometry of all of the pots and also to create the rebar modeling for all of the pots. Those fabrication models were then sent to Fort Miller, where they were taken directly into a robotic milling machine to mill foam formwork for the generation of the shape for each of the petals that created the pots. And then the pieces for the pots were shipped from Fort Miller's facility near Saratoga Springs to the Port of Coymans near Albany, where they were then assembled into the full pot shapes and shipped downriver to be erected on top of the piles by Weeks Marine.
My name is Signe Nielsen. I'm principal of MNLA with the landscape architects on the Little Island project. One of the most compelling images I saw at the outset of the project was as a leaf floating on the water. And so that's, in a way, how it has been envisioned. Part of the rationale behind the topography, and specifically the lifting of the south corners, is to allow the low angle of the sun to get under the pier to create greater light for the marine life underneath the pier. So we're now going to start up what we call Path 5, which is leading us to the southeast overlook and then down a surprise lawn. We're now passing some of the 110 trees in the park. We selected these based on, first of all, their success in other places in Hudson River Park, largely due to the size of their leaves. You notice here the leaves are very small, so the tree doesn't have a lot of mass to the wind. Looking at the sheet pile walls, it appears to be a lot of steel, but these plants will cascade over the top, and then we have plants that, including vines, that will grow up the sheet pile. We have native grasses here that will flop over and through the pickets. So you can see immediately in this image, as we're walking, we've got shade plants on one side and sun plants on the other side. So it's a very delicate and complicated planting design for all of the little microclimates that this design is creating. Now you get to the southeast overlook. So this is the highest point of the southeast. And you have a great view down to the access way. We changed the paving here because it's kind of a special place. There'll be a bench to rest on there. You'll be in the shade of this tree during the hot part of the day. So after you have enjoyed the view out and you see the historic arch that is in the process of being restored, you have a choice of going down onto this lawn, waiting for sod, or going down via a stair, or you could retrace your steps back on the paths.
This year has just been the most exciting. You can actually experience what New Yorkers are going to experience and really value what this park will be for New York.
Great. I hope everyone enjoyed the sneak peek of the project, and it's fun to relive all the steps. That the video makes it seem very easy. As you can see, we are joined today by our panelists, Signe Nielsen with MNLA, David Farnsworth with Arup, and Marty Leibrock with Hunter Roberts. And they'll take the floor to illuminate some of the challenges they had working on Little Island. So as we go into our discussion, feel free to pose any questions you may have in the chat for our closing. So Signe, I'll let you take it away.
Thanks so much. As I guess you saw in the video, I'll start by saying Signe Nielsen, a principal of MNLA, the landscape architects for Little Island. So we began the planting design by analyzing the various microclimates that you saw me discuss in the video. And as a result of both sun, topography, views, and wind, we end up with 9 different distinct zones. So we wanted to unify all of these zones into a single concept. And so the purple circle represents what we call the bloom sweep, that is a band of consistent color and plant types around the lower elevation of the pier. The biggest challenge, I think, was to coordinate the landscape's topography with the pot geometry. So we used thicker soils for the large trees and then geofoam to create the proper slopes for the paths. So that same view, as it looks today from the esplanade with all the trees installed, the north and the northeast favor evergreen trees to block views of the highway as well as the winter winds. The most topographically challenging area is the southwest that rises a full 62 feet above the water. Here's what it looked like a year ago. Then over the course of time, we added sheet pile retaining walls and geofoam to create the planting beds and the path slopes. So this is and now, so that was the sheet pile and geofoam. And now this same view this past week, you can see how the combination of foam and retaining walls result in a surficial topography that is quite different from the pot topography and pot surface. So as with any planting design, one builds up with trees. This has been incredible to watch the precision of logistics required to unload and install these trees. All of these trees have been carefully craned and into prepared holes, and then they are guyed to the deck to make sure that they remain stable in high winds. Then we end with the understory planting. These are the most sensitive to those microclimate variations that I mentioned earlier. So in all, this project has been a highly orchestrated coordination among an extraordinary team of folks that began years ago with this kind of 3D modeling to ensure that all of the elements would work together. And then my concluding image is, yet in addition to all of these incredible gymnastics, there are moments of delicacy and intimacy that I think will be as meaningful to the public as the blockbuster views. So now, David, explain our pots, please.
Great. Thanks, Signe. So yeah, I think, one of the biggest challenges for us at the early phases of the design was figuring out how to kind of balance the desires for all of this topography and all of the kind of unique geometry of the pot shapes with the need for finding a structural solution that was robust and durable and proven for the construction methods used in the Hudson River Park. The typical solution for precast is precast concrete for most of the piers around New York City. Hudson River Park in particular has over 20 years of experience with utilizing precast concrete. And precast concrete's normally most effective and cost efficient when you have lots of repetition so that you can generate multiple pieces from the same set of nice formwork. And that was quite different than the original kind of artistic renderings of the pier, which indicated a desire for lots of topography and lots of variation in shape. Some almost like a fantastical set of structural elements that are all unique. And we've managed to solve this puzzle by looking back in history and found an ancient tiling pattern called the chiropentagon. And it, at first glance, because the pier is actually the same plan shape for most of these pots. All the interior pots are all pentagonal on shape. They're not symmetric, and they're rotated, and they kind of rotate around each other and nestle perfectly within each other. And by taking that pattern and then just modifying the pots around the edge to get 3 more kind of edge pot shapes out of that typical chiropentagon pattern, we were able to effectively generate almost 80% of the pier surface with the same plan shape. And then by utilizing the same plan shape, it enabled kind of a typical pile grid, and also by then varying the elevation of those typical plan shapes, we generated 39 pot types. And using those 39 pot types, each with the same, a single set of formwork for those 39 pot types, we generated 655 pieces of precast out of those kind of 39 pot forms. If you go to the next slide, there's this just shows a couple of the different variations on a typical chiropentagon pot. So while all of these pots that you see on the screen, they're all the exact same plan shape as what's shown on the right there. And then each of the ones that's in the same row are actually all cast from the same set of formwork, even though there's distinct elevational variation differences between the elements within the same row. So basically, like, each pot type is the pot slopes up to a different angle or on a different side. And then once we hit kind of a tangential surface, we have kind of what we call the pot extension walls, which we utilize to cast the concrete kind of vertically up within that plan shape to achieve even more variation. So at the end of the day, we had those 39 different types of pot formwork, but created 656 unique petal shapes to create that geometry and to create the undulating topography of the pier. Marty, over to you.
Thanks, David, and good afternoon. My name is Marty Leibrock. I'm a project manager with Hunter Roberts Construction Group. We are the general contractor and construction manager on Little Island. So one of the challenges for us on this project was the massive offsite fabrication and assembly program that was required to fabricate the pots and the pier structure. The structure itself was built mostly off-site and then transported to the site, erected at the site with a very large floating barge crane. One of the most challenging aspects were the 655 unique precast concrete petals that make up the pots. So we had a great precaster in Fort Miller in upstate New York, and they had a production timeline that they had to adhere to, but there was also a need to follow somewhat of an assembly line sequence in order to meet that schedule. They wanted to produce the most alike petals sequentially for production and schedule purposes, but there were constraints on site related to which pot had to be erected first. That sequence of the erection on site was very specific, and it was driven by the temporary bracing and stability of the pots that was very closely coordinated between Fort Miller and Weeks Marine, who are 2 of our subcontractors, and Hunter Roberts, and also the not only the temporary bracing, but just the plain old logistics of starting in the corner of the site and working your way out. We were constrained on both sides of the site by the old timber pile fields, Pier 54 and Pier 56. And so we had to start in one corner and work our way to the southwest. So the images that you're seeing here are of that pot assembly operation up at the Port of Coymans in upstate New York. And we just had a great team of people between Fort Miller, the Port of Coymans, Weeks Marine, and Arup to make this thing come together and build the superstructure within the time frame that was required to deliver the project and have it open for next spring for for the enjoyment of New Yorkers and visitors to New York.
Great, thank you, Marty. And given the complexity of the project, yet the small footprint, there are many contractors on the site, different companies working every day off-site and on-site. Some of them are even competitors. How does your team keep morale high amongst all the different players? And does the design team or the client team play a role in this?
Yeah, so thanks, Celine. That's a great question. And, we're building a park, but we're building a park on an island. Building a park conceptually is a fairly straightforward process, but Little Island is an extremely complex build. There are many layers that go into it. The superstructure alone was a complex build. And then you add in the layers of the undulating topography, the theatrical infrastructure. We had to build an amphitheater on top of this thing. There's a back of house building that you see in this picture just to the left of the yellow crane. That'll ultimately be covered in a slope. But all of these things are happening on an island where there's really one way in and one way out across that south bridge that you see there. So there's a huge demand for space. There are thousands of cubic yards of cast in place concrete, thousands of cubic yards of planting soil, geofoam, gravel, all these different elements. And then on top of that, we have tens of thousands of plants that have to be installed on top of the structure. So there's a huge competition for space. There's a lot going on in this little 2.5 acre footprint. And sometimes, I find myself playing the role of almost the on-site psychologist to keep all of our trade subcontractors focused, keep them happy, keep them productive. Because like Celine said, there's a huge competition for space. Also, getting to the morale point, morale is a big thing. So, a lot of our workers on site or subcontracting partners, they all realize that they're building an iconic space and that they're building something that their families can ultimately come back to and enjoy for years to come. So that really plays a huge role in keeping morale high, keeping everyone productive, and really putting great quality work into place. So.
Great, thank you. And so it seems like from every layer of this job, boundaries have been pushed. And so I just wanted to talk to David and see if he's seen any shift in the industry since Little Island started.
Yeah, so there had been some precedents for digital fabrication, at scale. A lot around facades. Our SF MoMA project out in San Francisco had some robotically milled foam formwork for a glass fiber polymer facade, composite facade. But in general, like most of the concrete work in this realm has been more prototypes or university research type projects, and taking this milling, this digital fabrication milling process, to a project of this scale and magnitude, I think has been great. It's proven out that the prototypical work and the research work is viable, and that it's and in many ways it's the only reason that this park was feasible. Without that kind of direct digital and robotic process for the construction, I don't think we could have created these complex geometric forms out of precast concrete and gotten all of these pieces to line up the way that they did. So I think that as the project has gone by, I think a lot of people are looking at it and saying, "Wow, look at that concrete! How was that made?" And hopefully we're going to see more interesting, precast concrete used throughout the industry moving forward in the future. Hopefully, we spark some great ideas.
Yeah, I think we will. And I just want to say thank you to you and your team for educating the client team and the contractors along the way for how do we get your computers to talk to their computers and what equipment is needed on all sides in order to actually build these things. And so I'm excited to see what people can think of next, knowing that you were able to just take dumb old concrete and make it perform the way that it performed out on Little Island. And your team was really instrumental in that.
Yeah, thanks. It was good fun. Looking for the next one.
Yes, sure. So I'd like to ask Signe the next question. So Signe, based on your experience and decades in New York City, transforming the city, what it is today with quality open space and numerous parks, do you feel that Little Island will set a precedent for the next park typology?
I certainly hope it does, and thank you for that question. Little Island is specifically designed to be flexible and responsive, to people every day of the year. So my experience over the years has been that we're typically asked to cram in a huge amount of single-purpose programming like sports courts, playgrounds, senior fitness equipment, so that the park spaces ultimately are quite inflexible. Some even go out of fashion as people's physical preferences, activity preferences change. To me, the beauty of Little Island is that while there are places that can be programmed, they are equally convivial gathering spaces for individuals and large groups, all at the same time. So my hope is that actually Little Island will set a new paradigm for the 21st century in park design that in fact recalls the kind of leisure and sense of wonder that we found in 19th century parks such as Prospect and Central Park. And I'll just add one more thing, that this park also sets a different standard on resiliency to climate change because the park is actually elevated as opposed to having a soft edge that will ultimately be subject to nuisance flooding and then ultimately potentially disappearing. So in this case, Little Island literally rises above those threats.
Great, thank you for that, Signe. And since I have you on, I just want to know, what is your biggest joy working on this project?
Oh, there's been many joys. I'm certainly enjoying being out there doing the helping with the planting, but I think that in the big picture, since we've been at this now for almost 7 years, it's been the client and design and construction teams collaborating together. It is really, in all of my 40 years, I dare say, of experience, this has never been so true as it is on this project. And I know that we all, as Marty said about the contractors, I know that we all share the same goal in making this a great place for New Yorkers. But I do want to add one more thing, which is that it's said in the design field that a great design is the result of a great client. And indeed, you and the others on the client side are deeply engaged, thoughtful, committed, and have pushed me personally to be the best I can be.
Great there. So let's have David and Marty join us. It's going to be hard to beat that, but Signe's hard to beat. So David, how about you go next?
Yeah, if you can't beat them, join them. So I think in many ways I'd echo Signe's sentiment. I think the best parts about the project, other than having it here in New York City, and it's a place that my daughter and son can go to and say, my dad worked on that. It's definitely been the collaboration. When we started the project, we hit it off very well with the design team, and that's fairly common for projects. I feel like we hit great synergy on that front. And then things really started to get interesting when we started looking for contractors, and we had a pretty long, extended, kind of interview process, and we went out and we talked to a lot of different people to understand capabilities, and that influenced the design. For instance, when we were looking for the precast supplier, we probably visited 10 different precast plants, looking for the right partner, the right people who are willing to try something new. Fort Miller didn't robotically mill foam formwork before this project. They've now started a company that does that, and they're applying it on other things, which is just awesome. And the way that that we did that was one, having an understanding client, two, having great design team partners who were flexible in the way that they were looking at things, and we changed our design to suit the capabilities of the industry, and a great team and Hunter Roberts in order to pull everybody together, get things contracted in a way that mitigated everybody's risk. And I'd say that some of the things that we did on the design team side were really blurring the typical boundaries between design and contractors. My chief counsel would probably kill me if he realized half the things that I did. We were modeling rebar. We were directly cutting steel shapes out of our models. It's all these things that, where if things go wrong, design teams get sued. And I think, a lot of those blurring of the boundaries and taking that true collaborative relationship across the design team into the contracting team, was the recipe for success on this project and one of the most fulfilling parts.
So I'm just going to echo what David and Signe said. I mean, the collaboration, the relationships that we've built off of this project are just second to none. And to cut it short, not to say everything that they just said, I think we're going to have a ton of great stories that we can all look back on over the years and reminisce. And I've had a lot of fun. Our whole team has had a lot of fun. And I think it's going to be great looking back on it. It really is.
Yeah, it's been so much fun working with you all. I love that now I can call you friends, and, we're missing Heather Wick and Lisa Rutledge and Fisher Moran and the rest of the team. But as someone who's part of the team that holds your contract, I know contracts are important, but the relationships build this job. And David, as you mentioned, there are some things that maybe you technically shouldn't have done, or your counsel wouldn't have appreciated it, but the client appreciated it and the client noted it. And I know that Marty really just loved how much you guys stepped up to teach the team and to provide them that extra support from your computer modeling. And same with Signe, she's out there every day, moving around plants and having her join us when we are remote, which is always fun. And so team, I just want to thank you so much. And, of course, Marty, you're always so collaborative with your team, with Kevin and Brian. And we really appreciate just how this entire group has linked arms and said, we are going to build something fantastic for New York. And it's happening. And honestly, it's going to be a little bit sad when we're done. We're going to have to find our next thing. So now we're going to go ahead and turn it over to the questions from the audience. We have about 15 minutes remaining. So feel free to post your questions. So the first question is, I understand the rebar layout being designed with computer modeling. How did the contractor fabricate the rebar in those complex shapes? So David, that's for you.
Yeah, so the rebar, it was interesting. When we modeled the rebar, we kind of basically built on the parametric script that we had generated for the interior geometry. So we had all of that done in Grasshopper, and we basically took that as the starting point, and then offset the surfaces and started slicing it up in order to generate the rebar shapes and spacing. And so we provided the rebar in kind of an instantiated 3D formwork, and the rebar within the pedal was there in 3D, and each bar was individually tagged. But then we also exploded those models and laid all of the rebar flat so that they could basically generate single bar bend diagrams out of each and every bar, which had the same tag, which they could then go to the 3D model to reference like how it was to be placed. But they had an individual. It almost looked like in the Rhino model, it looked like a work yard or a storage yard out in the side, next to the 3D model, and it was all set up in a matrix with a little tag underneath saying which bar it was. And so for bars under a certain size, they can use an automatic bar bender that just programs in that bar bend. But a lot of those bars that they had the things printed out and manually bent, and then placed in the model.
Yeah, I was shocked when we went up there, and it was just like a little kid set where everything was printed, and they were taking them and checking to make sure they were the right shape, and it was taller than I am, so it's really incredible.
That's right. Sorry, go ahead. We can move forward. I was just going to add, the digital fabrication process of it was great. There was, like David was alluding to, there was definitely a bit of just, old-fashioned, the way most precasters do it. There was a bit of old-fashioned work involved in bending these rebar pieces to the shapes. However, it was a tedious process. I mean, I can't imagine. I don't even know how many tons of rebar were put into these pedals. So it was definitely a great process the whole way through.
Yeah. So Marty, maybe you're able to answer this next question. I know we don't have our marine engineer joining us today, but the question is, how deep are the piles, and were there any issues driving them?
Sure. So the piles range anywhere from 90 feet below mean water level to 210 feet below mean water level. Most of the piles are driven to bedrock. There's a handful of piles at the southwest corner that are friction piles driven into glacial till. Overall, the pile driving program was definitely successful. I think the biggest challenge that we had in pile driving was location as it relates to the specific geometry of the already precast pots. So in order to make our schedule and due to site logistics, we had to drive piles ahead, or we had to build pots ahead of driving piles. So if we're driving a pile and then the pile wants to walk a couple inches left or right, making sure that those pots actually all fit together at the end of the day, that was our biggest challenge. We had a couple of instances where piles had to be pulled in a couple inches, either left or right, north, south, whatever the case may be, in order to make these pots fit. 2 instances where we had to refabricate a pedal with a slightly different geometry in order to make it all fit. But at the end of the day, it all came together. So it was a great process.
So you already answered one. Oh, go ahead, David.
I was just going to say, within the design, we'd had a 9-inch gap, basically between a theoretical 9-inch gap between each pot, in order to allow for those tolerances. And when we were selecting Weeks Marine as the marine contractor, there was a lot of credit given to the fact that they had one of the largest and a fixed driving rig that could position these piles within an inch of where they're supposed to be. And one of the things that was somewhat surprising was that as we were driving piles, they were getting them put in exactly the right spot, within an inch of where they're supposed to be. But then as we were driving piles, as you moved out, the addition of the piles into the water were actually pushing some of the piles that we had already driven in. And so most of the areas where the piles were out of tolerance wasn't due to any sort of contract error or any sort of significant obstructions. It was actually that the riverbed was moving as we were displacing volume. But luckily that all fell within the tolerance range of the pots with the 2 exceptions. So it was good that we had 9 inches of slop between the pots, or we could have gotten into real trouble.
Sure. And so, Signe, was there anything on the job that was surprising to you, or that may have gone a little bit differently during the build?
Well, in that beautiful picture you saw of that huge tree being brought on site, we had went to a lot of different nurseries to select these trees, and one arrived, and it was actually broken. Many of its branches were broken, and it was really a heartbreak because we had looked hard for that tree. So we immediately called up the buyer for the landscape contractor and said, any chance you can find us another 12-inch Colretaria? And within an hour, he said, I found 2. I'll go take a look at them, send you photographs, and we can have it there in a week. So, it was, we don't know how it broke, whether it was damage from the trucking or whatever, but it's just surprising that we could find another one and get it in. But it's all about timing and these great people on this job and this silly cat.
And what's next for the historic arch form?
So just a little bit of background maybe folks would like to hear, and then I'll let Marty, no doubt, talk about it. This is one of the remaining arches from the 6 head houses of the White Star and Cunard lines that really are about the era of the passenger ship era. And of course, Pier 54, which this is a view of before it was demolished, is the place where the survivors of the Titanic were brought. And so it has not only a long history of many ships sailing from it, including also the Lusitania and the Carpathia, but also because of its, significance in a couple of major sea tragedies. So the arch is being kept exactly in its place. We've even kept the patina of the White Star and Cunard Line paint on the east facade, and the only thing that's been done to it is really to help fix some of the bits of steel that had been damaged over the years. But I don't know, and there'll be some dramatic uplighting on it, which I think will really be quite beautiful. I don't know, Marty, anything else you want to add to that?
Yeah, so we've done, we've done some structural repairs to the arch, but really, I mean, we just took the scaffolding down this past week, and so it looks the same as it did before we got started. But there were some structural repairs done, patching some of the holes that you see on the right-hand side there. But ultimately, it was preserved in its original condition. And like I said, we took the scaffolding down, and I'm like, we didn't really do anything. but it's now structurally sound, and it's a nice piece of history right at the south axis we're there.
Yeah, it looks lovely. So, Signe, I want to toss this question back to you. Can you share with us like the animal habitat that has arrived, or do you think that we need to bring animals to the site?
Well, it's been really fascinating. I mean, yes, intentionally, we used a number of trees that produce fruit, and also a tremendous number of pollinators in the perennials. So I've been watching, since I'm there virtually every day, who's arriving. And of course, we start out with the sparrows, not so fascinating. But the other day, I found a praying mantis, a cardinal, which was really remarkable. And then once we planted the asters, we're just filled with lots of different pollinator bees. So I am thrilled to say that within 3 months, we have really brought in, or we, not us, that the plant material is beginning to create the habitat that I hoped it would. So I don't think we need to do any importing.
Great. And for better for worse, when I was leaving the site, Signe, I saw one of the birds take the praying mantis and was eating it in the tree. So there's all the natural cycle already happening before we even are finished with the planting. So here's another question. I'd love to know, how does this project fit in with the Big U initiative and its goal for coastal resiliency?
Well, I guess I ought to take that one. So yes, our firm is working on the Big U on the east side, between 26th and Montgomery Street, and in that case, we're putting up a wall as well as elevating parts of the parks. So what I was alluding to in terms of what I think that this little island sets as a precedent for the future is actually elevating it out of harm's way, and way out of harm's way. I mean, it's above the 500-year floodplain for 2050, and combined with an aggressive sea level rise prediction. Now, the problem is that the esplanade is actually almost 10 feet lower. So that's all I can say about Little Island. How we're going to get to Little Island once the esplanade is underwater, I have no real idea. But this is a totally different strategy than what the Big U is proposing elsewhere around Lower Manhattan.
Well, it seemed like it's what was appropriate, given that the west side is not being elevated. So at least this project is ready should there be a plan that loops around Manhattan.
Yeah.
Great. And Signe, do you want to just share your design, the way that you're our executive landscape architect, and how you integrated with Heatherwick Studios and with Arup and Musa Rutledge? What was that team dynamic like?
Well, I guess I would say that, yes, okay, executive landscape architect really sounds a little scary. And
Okay,
I
local
have
landscape architects. We do have our executive architects with standard architects, but we do have our designers in London. You are here. What is that collaboration? How does that look for people who only work with designers stateside? What does that look like to be a global team?
Well, I would say that, long before the pandemic, we became Zoom masters because we would be speaking with Heatherwick probably 3 or 4 times a week. We would share, we had a model, and we shared this model among the design team. Arup obviously contributed to it, all of Arup's disciplines, including mechanical, electrical, civil, as well as structural. So this model was sort of the lifeblood of the project. And if let's just say that I wanted to plant trees here and there, I would put them in the model. We'd send it to David's team. He would say, "No way, Signe, that pile is totally overloaded. Can't put it there. Move it." Then I would talk to Heatherwick about, do you really want a 40-foot tree there? Could we do a 20-foot tree? Because it was just this constant balance of the weight, the soil volume, and the kind of calibration of the trees. I mean, you saw in that elevation as well as in the video that one of the great things I like about the landscape design is that the trees are of all different sizes. So it doesn't just look like it's starting out at a 3-year baseline of tree age. It's all different that way. So it was, we would constantly be going back and forth. Heatherwick would get a great idea. We would do the research on whether that material can be domestically sourced, and then there wasn't a decision made that wasn't a collaborative decision, but it was really based on using this model.
David, do you want to add to that?
Yeah, I mean, the workflow for the generation of the geometry was really quite interesting for our team, and integrating that with all the different players on the project. Certainly the complex geometry generation was good fun, and we worked integrally, creating scripts between ourselves and Heatherwick to generate the interior and exterior surfaces, and making just sure that we all knew what we needed, both to kind of define the geometry from the design and architectural perspective, but also to define the design with the clear intention of passing it on for fabrication. So that was good fun, and I've personally worked on a lot of international projects, so the idea of working with international consultants doesn't seem too new for me. But yeah, it's like Signe says, we're lots of conference calls and Zoom calls and sketching on screen, and luckily we were able to form good kind of trusted bonds between all of the different team members in the time before the pandemic. Nights out together and workshops together where we really started to trust each other and know that we all had the project's best interest at heart.
Great. And I just want to throw this one to Marty. Marty, we hired your company earlier in the project to really guide us along the ways. Did you use this model? Or I know you did. How did you use this model to feed back with the designers and the client team about what we were trying to tackle?
Yeah, I mean, it was a hugely collaborative effort in pre-con, and there were, I would say that the amount of effort that went into pre-con is just as great as what went into the actual construction effort. I mean, from a cost estimating standpoint, we had the subcontracting community engaged early. As David said, we really talked to many different precasters. And it took a lot of work to home in on Fort Miller as the right people to do this job. It took a lot of effort to home in on Weeks Marine as the right people to drive the piles and erect the pots. And, they had the capability and they were putting forth the foresight, and they were fully integrated. David, I think, can attest to this. They were fully integrated in the 3D modeling effort. I've worked with very few contractors who have had that sort of taken that sort of initiative in the design phase, in the 3D modeling phase, to make sure that what was being laid out would actually come to life. And so that, that went a long way in actually building this structure.
Great. So thank you guys for being a part of our panel discussion today. And thank you everyone for joining us. Thank you to Barry Diller and the Diller von Furstenberg Family Foundation for making this unique project possible, and for New York City. Thank you to the Open House New York team for the opportunity to share our park. And again, panelists, thank you for making yourselves available on a Saturday. So everyone tuning in, please follow Little Island NYC on social media. Sign up for our mailing list if you want to learn more. And we're excited to see you out at the project in spring of 2021. Thank you.
Thank you.